Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. So today in this video lecture, I am going to discuss about the methods of measurement, and in this I am going to explain the numerical methods of the methods of measurement. So in the previous classes, we have discussed about the what are the indication of surface textures, different terms and values and numerical forms we have seen, and we have seen the symbol of lay methods and the factors affecting the surface roughness. And order of the geometrical irregularities and some surface finish points. And next, we are going to see the methods of measurement of the surface roughness. So, what are the different methods of measurements of the surface roughness? So, generally, there are basically two methods for measuring the surface finish, and the two methods are: first one is the comparative or qualitative methods, and second one is the direct method or quantitative methods. So that is direct measurement or quantitative methods measurement. Coming to the first one, comparative or qualitative methods. So in these methods, the surface texture is assessed by the observation of the surface. So generally, the surface texture is measured by the only the observation of the surface, by seeing or touching the surface only, but not by any other testing measurement. And the surface to be tested is compared with the known value of roughness specimen. So generally the surface is to be tested with the known values of the specimen roughness, and it is finished by similar machining processes. So the similar machining processes is to be finished by the roughness of the specimen processes. And the various methods which are used for this type of comparison are, these are these 6 types of various inspection methods have been used. First one is the touch inspection, second one is the visual inspection, third one microscopic inspection, fourth one is the scratch inspection, fifth one Microamphometer inspection, and last one is the surface photographs inspection. So by seeing the surface photographs only. So in the first one, it is the touch inspection. So in the touch inspection, you can only measure it by the touching the surface area with your hands or fingers. And second one is the visual inspection. So these visual inspection can be seen by the only by seeing only with our eyes only. So that is the visual inspection. Third one is the microscopic inspection. So in this microscopic inspection, the inspection is done by using the microscope only. So next one is the scratch inspection. So by verifying the scratches in the surface texture, we can see the scratch inspection. And next one is the microamphometer. So for this microamphometer, we can specify it by the optical lens only. Next one is the surface photographs. So by this surface photographs method, we can verify the surface finish by only the photographs only. So these are the different types of methods of measurement in the comparative or qualitative methods. So in that first one is the touch inspection. In the touch inspection, the main limitation of this method is that the degree of surface roughness that can't be assessed. So by touching the surface, we cannot assess the surface roughness directly. So that is the main problem with it. Also, the minute flaws can't be detected. So the minute flaws can't be detected from this touch inspection, and this method can simply tell which surface is more rough. And in this method, the fingertip is moved along the surface at a speed of about 25 mm per second, and the irregularities as small as 0.01 mm can be easily detected. That is the size of the grain size. So we can easily detect the size of grain sizes, but the smaller object than the that one cannot be detected by the touch inspection. And second one is the visual inspection. So in this method of visual inspection, the surface is inspected by naked eye, and this measurement is limited to rough surfaces. So the measurement is limited to rough surfaces only, and this is inspected by our own naked eye only. Next, microscopic inspection, and this is the probably the best method for examining the surface finish, but due to limitations that only having a small portion of the surface has to be inspected at a time. So when you are going to inspect only a small portion of the surface can be inspected at a time. So larger surface area can be inspected within small proportion only, but not at a single time. And thus several readings are required to get an average value. So these readings are required to get an average value, that is the sampling program. And in this method, a master finished surface is placed under the microscope and it is compared with the surface under inspection. So that is the surface under inspection. So that is the surface under inspection. And in other method, a straight edge is placed on the surface to be inspected and a beam of light projected at about 60 degrees to the work. So a beam of light can be projected at about 60 degrees of the work, and this allows the shadows casting into the surface scratches which are magnified in the lens of the microscope. So this can be magnified in the lens of a microscope and the surface irregularities can be studied. So these can be studied easily with the help of these microscopes. Next one is the scratch inspection. So in this method of scratch inspection, a softer material like lead babbitt or plastic is rubbed over the surface to be inspected. So this is rubbed over the surface to be inspected, and this can be done so that it carries the impression of the scratches on the surfaces which can be easily visualized. So by doing this, it can be easily visualized. So that is the scratch inspection. Next one is the Microamphometer. So in this microamphometer, the method, an optical flat is placed on the surface to be tested and it is illuminated by a monochromatic source of light. So monochromatic source of light has different variants, that is the mercury vapor lamp and incandescent lamp and any other lamps. So it is depending upon the purpose, and we can use any type of monochromatic source of light, and these interference bands are studied through a microscope only. So these interference bands are studied through a microscope and it can be detected by the defects. So the defects, that is the scratches in the surface, appear as interference lines extending from the dark bands into the bright bands. So we can clearly see the difference there, the difference between the dark bands going to the bright bands. And next one is the surface photographs. So in this method, magnified photographs of the surface are taken with different types of illumination. So different types of angles has been taken. And in case we use the vertical illumination, then defects like irregularities and scratches appear as dark spots, and flat portion of the surface appears as the bright area. So these can be extended to the bright area also. And in case of oblique illumination, reverse is the case. So when you are going to oblique in illumination, we are going to reverse the case. And last one point, photographs with different illumination are compared and the results have been assessed at that point. So the results have been assessed with that point. And next one we go to the numerical methods of the surface finish. So first one is the center line average method. So we are going to call it shortly CLA method. So in the university exam, they are going to ask you any two of the methods. Explain you any two of the methods. So first one is the CLA method, that is center line average method. So in this method, the surface roughness is measured as the average deviation from the nominal surface. So from the nominal surface point of view, it is taken as the average deviation. So in that, we have to draw a diagram. So this is the CLA method diagram. So we are going to draw a nominal surface, and the positive loop and negative loops has been drawn as the areas of A1, A2, A3 and so on. So when we have obtained 6 or 7 areas, we are going to draw it to A1 to A6. And in every section of area, so we have taken the A1 as the section of area, we are dividing the section into equal proportionates. So we are drawing the section into equal proportionates, and dividing into 5 ways. So 5 areas, 5 lines have been divided. So these 5 lines have 5 different heights. So we are measuring the different heights and we are going to take it as the average length of the section or area. So next the process is same for the remaining areas also, that is A2, A3, A4 and A5. So it is defined as the average value of the ordinates. So these are the ordinate points and we are going to take the average value of these ordinate points from the mean line. So this is the mean line for the open loop and closed loops, that is the positive and negative loops, regardless of the arithmetic sign of coordinates. So we are taking all the positive values for all the coordinate lines, and the value for the CLA is, that is the CLA value is H1 plus H2 plus H3 plus and so on to H of n divided by n value. So these heights is measured to the section between the elements, that is these are the H1, H2, H3, H4 and H5. So for each area of section we have to determine this value, that is H1 plus H2 plus H3 plus so on Hn by n. And the next, the main value is to be obtained as, that is CLA value is equal to A1 plus A2 plus A3 plus A4 plus and so on to An divided by total length of the sampling. So that is the total length of the sampling has been taken in this section, that is equal to sigma A by L. So this is the first equation and this is the second equation. In the first equation we are going to divide it into individual areas and all the individual areas are combined in this second equation. Next one, so this center line average method is also called as RA method. So shortly it is also known as RA method. So in the syllabus papers also it is taken as RA. So RA is the average height from a mean line of all ordinates of the surface regardless of the sign. Regardless of the sign. And it is taken as y1, y2. So we are taking at any points. So h1, h2, h3 or y1, y2, y3 be the height of the equally spaced ordinates at positions 1 and 2. So these are the equally spaced options. And in the center line average method, the center line average is taken as y1 plus y2 plus y3. So these are the three ordinates in the specified area. We are taking it as this, and plus yn by n. N is the number of ordinates taken. So if we have only three elements, that is three ordinates, we are taking the n as 3 only. And the origin position and the final position is indicated by the sampling length. So that is the end of the sampling length we are taken. So another way of calculating the RA value, that is the CA value, is shown in this figure. So by taking all the areas, that is the area 1, area 2, area 3, area 4 and area 5, and total length as capital L, that is the sampling length, and the value for the CLA is taken as, that is CLA value is taken as A1 plus, A2 plus, A3 plus, and so on. So A1 plus, A2 plus, A3 plus, and so on, AN by L. So the total number of areas can be taken with the measurement divided by length, that is the sampling length. So the total CLA value is taken as sigma A by L, that is the average area divided by the total length of the sampling, that is the sampling length. So sigma A by L, as per the BAS, that is British Bureau of Indian Standards, the surface roughness is assessment in terms of CLA value, and it is denoted by the value RA, that is the RA value. So it is denoted as the term RA. So it can be specified in the term RA value. So this is of the CLA value, that is center line average. Next one is the root mean square. So shortly it is known as the RMS value. So in these, the surface roughness is measured as the average deviation from the nominal surface. So we are taking the nominal surface as the surface roughness value. So that is the average line, and it is defined as the square root of the arithmetic mean of the values of square of coordinates of the surface measured from the mean line. So it is taken as the square values for every element, that is for every coordinate they are going to take the square values. So here you can see the y1 square, y2 square and so on, yn square. But in the centralized average method, that is CLA method, we have directly taken the measurement length of the ordinates. But here we are going to take it with a square root, and the ordinate can be taken as the square element, that is y1 square plus y2 square and so on, yn square divided by small n. So these ordinates length has been taken from the arithmetic mean length. So in the CLA method procedure, only this can be taken. So this is the area of the first section, second section, third, fourth and fifth sections. So we are dividing the coordinates lines of equal length. So that is 1, 2, 3, 4, 5 lengths. So y1, y2, y3, y4 and y5 length. So the length of the ordinates can be seen here and be measured in the terms of square. So you are taking this square and the origin point and the ending point length has been taken as the capital L, that is the sampling length, and the formula for the RMS is, that is a average value for the RMS value is root of y1 square plus y2 square plus so on yn square divided by n. So that is the nth term of the y ordinate with respect to n value. That is the divided by n. And these terms can be defined in the value of square value only. Square, that is the square root value of arithmetic mean of values of square of ordinates of the surfaces measured from mean line. So these can be the surfaces measured from the mean line, and these ordinates of the RMS value of y can be taken as y RMS is taken as root square of 0 to L y square dl. So this is the value for the addition of that value. So that is the formula for that value. So the shortest form is known as RMS. So there is no another term for this RMS value. So it is taken as root mean square. So in the heading only you can take the meaning, that is root mean square. So we are taking the square root of the mean line with a square applied to each coordinate. So that is the meaning of root mean square. And then we go to the last point in the numerical assessment of surface finish, that is the measurement of surface finish. So third one is the 10-point height method. So in this 10-point height method, the average difference between 5 height peaks and the 5 lowest valleys of the surface texture within sampling length is measured from a line parallel to mean line and not crossing the profile. So in this 10-point height method of profile, we are seeing the different samplings of length. So these are the different samplings, so different ordinates which extend the points to 10 points. So 10 type of irregularities have been taken. In that, 5 type of irregularities is in the peak stage, that is the highest point, and the 5 other points is in the valley section, that is in the lowest point. So these are the 10-point heights of this section, and from the first point, starting of the first point and the ending of the 10th point, we are taking it as the sampling length. So the sampling length here have been taken for the 10 points section. Here in the picture you can see. So these are the R1, R2, R3, R4, R5, R6 and up to R10. So how it is taken? So first we are going to the peaks. There are 5 peaks and we are starting from the right side of the portion. So right side will start just measurement అనేది. So the first peak valley, sorry, the first peak height is taken as R1. The first height point is taken as, that is height peak is taken as R1, and third height peak is taken as, that is the third point of peak height is taken as R2, that is the second value for the radius R, and fifth point of height peak is taken as R3. So fifth point of height peak is taken as R3, and fourth point is taken as R4, and second point is taken as R5. So these are the 5 height peak points in which it starts from the right side portion, that is the R1, and I am going for the optional one. So peak after peak, alternate one. So R1, and next alternate one, that is R2, that is third one. Next R3, and next we are continuing the R4 and R5 for the remaining peaks. So those are the peaks positions, and next the remaining 5 are the valley positions in which from the R6 to R10. So it takes from the positions R6 to R10. So in this valley, so valleys means the lowest points, peaks means the highest points of a curve. So we are starting from the left side. So it is taken as R6. So that is taken as R6. And next one it is the R7. That is the second valley point is the R7. And third valley point it is the R8. And fourth valley point it is the R9. And last one is the R10 point. So these valley points are taken from the left side of the total sampling length, and the peak height measures are taken from the right side portion. So these are drawing of the 10-point height method. So for measuring, and it is the simplest method to measure the total depth of the surface irregularities, but it does not give sufficient information about the surface. It only gives the average value of the surface, but it does not give the total sufficient information, as no account is taken of the frequency of the irregularities. So no account of the is taken on the frequency of irregularities. So that is of the 10 point, and if you are going to take these points for the formula section, R is taken as the 10-point height of irregularities. So that is capital R is denoted as 10-point height of irregularities. So we can derive the formula, that is R is equal to 1 by 5. So 5 value is taken for the 5 peak valleys, or sorry, 5 peak heights or 5 valley heights. So that is I am taking it as 1 by 5. So there are two types of elements, that is 5 is the peaks and 5 is the valleys. So I am having the common value as 5. So I am taking this 5, 1 by 5 into, first is the valley peaks heights, that is R1 plus R2 plus R3 plus R4 plus R5. So I am taking the heights of the peaks, that is from R1 to R5. And next I am taking the valley points, that is R6 to R10, and I am taking the subtraction of that point, that is 1 by 5 into R1 plus R2 plus R3 R4 R5 minus R6, R7, R8, R9 and R10. So these are the 10-point heights of irregularities with respect to the 5 height peaks and 5 lowest valleys of the sampling, of the surface texture within the sampling length. So these are the different elements and different numerical assessments of the surface finish. And in the next class, we are going to see the direct measurement. So we have some more methods for the measurement of surface finish. We are going to calculate that one also. So we are going to see that one also. By this, I am ending this class. In the next class, we can see the measurement of surface mesh and different methods of surface mesh, that is the profilometer, Tomlinson surface meter, and Taylor-Hobson and etc. and construction of that. Thank you.